Good morning, welcome to Sense of Science. So we are continuing our journey for learning genetics and understanding the questions. So this video is about question number 6 from the NCERT. Using a Punnett square, work out the distribution of phenotypic features in the first filial generation, that means the F1 generation, after a cross between a homozygous female and a heterozygous male for single locus. Now I have talked about locus as one of my previous video. Locus is a site where gene is present. If single locus means there is only one gene, so we are comparing only one trait, and when we are comparing one trait, the cross becomes monohybrid. That's the first thing we can infer from here. Okay, so that's the first thing. You have not been given whether the cross is monohybrid or dihybrid, but you have been given a single locus. Single locus means one gene. One gene means monohybrid. Two genes means dihybrid. Okay. Now the cross is between the phenotypic features of the F1 generation between a homozygous female and heterozygous male. Now we are not given what gene we have to do. We can take up any gene. So I can take up the simplest one. We can take up the gene for tallness. Okay, we can compare the gene for tallness. So firstly, talking about the parents, from here we have been given that the parents are homozygous female. Okay, so let me take up the homozygous female as a tall female. Okay, heterozygous male will be this. You can do the same for the dwarf also. Okay, so heterozygous male is this. Fine, so this is homozygous female and this is heterozygous male. So first of all, in any step before going on to the cross, we need to write about the gametes. What will be the gametes from this? The gametes from this will be capital T, from this it will be capital T, small t. Now to find out the F1 generation, you can do it either by the crisscrossing method or by the Punnett square, but here they have specified Punnett square, so we have to use Punnett square. So let's do the F1 generation now using the Punnett square. So in Punnett square, what you do is you create a square, and in the first row and first column, both you write the gametes. So in the first row, let me write the female gametes, which is this and this, and in the first column I write the female gametes, and in the first row let me write the male gametes. Okay, then you make the square. Okay, make sure that the grids are same so that it becomes a square, and you have to write the possibilities now in this. So it's simple, just cross this with this, you get the first column, that is capital T, this with this one with this one. For the second column, that is again a capital T. Then you do this one with this one for this box. So this becomes a capital T, small t. And then you do the final one as well, this one with this one. Capital T, small t. Okay. Is that fine? So this becomes your F1 generation. So in Punnett square, just cross the row with the column. That's easy to do. Alright, so now we have to work about the phenotypic ratio. Now what you can see is the two gametes which you can see here. I'll change the color. Two gametes which you see here are homozygous tall. Capital T means homozygous tall. Whereas two gametes which you see here, capital T and small t, they will also be tall because capital T is a dominant trait, but they are heterozygous tall. But when we compare this in the phenotypic ratio, in terms of phenotype, all are tall. So there is no ratio because all are tall, whether they are homozygous or heterozygous, all of them are tall. But if you are asked the same question for genotype, your answer will change. Your genotype becomes 1:2:2, that is 2 homozygous tall versus 2 heterozygous tall, which further simplifies to 1:1. Okay, this is for 2 homozygous tall, homotalls, which is your capital T, whereas 2 become your heterozygous tall, which is capital T and small t. Okay, but if whether it's homozygous or heterozygous, all of them will be tall. So in phenotype, all are tall, but in genotype, 2 are heterozygously tall, but 2 are homozygous. But in the end, all of them are of course tall because capital T is a dominant trait. Again, for understanding these kinds of questions, the basics of a monohybrid cross, dominance and recessive traits has to be clear. I have made a video on this. I can make more. If you want, please do write in the comment section for that. So with that, we close off with this question. Stay tuned. More questions and more interesting concepts are coming in your way. Take care. Bye bye. Thank you.